Okay, we're looking at hypothesis testing about a population mean mu when the population standard deviation sigma is known. Your test statistic is given as z is equal to x bar minus mu over sigma over the square root of n. You remember seeing that in the central limit theorem when we're doing the samples there. We will be calculating the test statistic using technology. And we're going to use p-values to determine whether there's two options. Either you fail to reject your null, or you reject your null in favor of the alternative and conclude and you roll a statement out. So your p-value is going to be the probability of getting a value of the test statistic that is as at least as extreme as the test statistic calculated, assuming that the null is true. So, but it basically comes down to is, if p is less than or equal to alpha, you're going to reject the null in favor of the alternative. If p is greater than alpha, you just simply fail to reject the null, and that's all you do. And there's not sufficient evidence to conclude that it's any different than what the null stated. Another thing we're going to be looking at is type 1 and type 2 errors. Your type 1 error is denoted by alpha, so you're going to have a significance level to test by, just like we did in confidence intervals. And so a type 1 error happens when we reject the null when we really shouldn't. Okay? So the probability of a type 1 error is alpha. A type 2 error, which is denoted by beta, which is kind of like a V with a long line here on the left, happens when we fail to reject the null when we should. Okay. Now, if you're going to find the probability of beta, now we know what the probability of alpha is, or the type 1 error, which is simply your alpha level. To find the probability of beta, it requires a pair of hypothesis tests, which we will not cover in this class. So, just want to be complete there. Alright. So, let's look at what we're given here. The Food and Drug Administration, or the FDA, is a U.S. government agency that regulates food and drugs for consumer safety. So one thing the FDA regulates is the allowable insect parts in various foods. And I tell you what, I did not know this at all until I saw this example. And it is true. So everything in here is from real data. So you may be surprised to know that much of the processed food we eat contains insect parts. Oh, Lordy. An example is flour, okay? So when wheat is ground into flour, insects that were in the wheat are ground up as well. Now, the mean number of insect parts allowed in 100 grams, or about 3 ounces of wheat flour. So here's our mean. Mu is equal to 75. Okay. If the FDA finds more than this number, they conduct further tests to determine if the flour is too contaminated by insect parts to be fit for human consumption. Does that not gross you out? So anyway, does me. Now notice that it gives us the population standard deviation. So sigma is equal to 9. The FDA cannot afford to sample the entire shipment, obviously, or take a census of the shipment, so they take a random sample of N with 37, and they find that X bar is equal to 78.6. So, that being greater than that, I'm thinking it's going to be contaminated, but we'll go on and do the test and see at the alpha level. So test to see if the entire shipment of wheat is not fit for human consumption. Again, that's a little scary thought. Alpha is equal to 0.10. Okay, so our H sub 0, or null, would be that mu percent is equal to 75. Well, we're going to test the claim that it's unfit for human consumption. So we're going to say the alternative would be that mu is greater than 75. I'll put those things in right now. Remember, hypothesis and nulls are always equal. 75. Alternatives are either less than, greater than, or not equal alternative would be mu is greater than 75. Now find the test statistics. So I'm going to do the TI, and I'm also going to do stat disk. In stat disk, you have to do a little extra thing that you do in the TI. So let's go here, clear that out. Let's go to stat test. Yeah, okay, z-test, that's what I wanted. Let me go again. Stat test, and I want the z-test. And we're going to be inputting stats. Now, you would input data if you had L1 and L2. So, mu sub 0 is, actually, this is 75. Okay, it's already in there. Sigma is going to be 9. Okay, X bar is 78.6. N is 37. It's our 37. Now, this is our alternative. So the alternative is that mu is greater than that. So it's already selected there for you, but enter it again if you need to. Go down here and say to calculate. Okay. Z is equal to 2.4331. Now here's my p-value. P is equal to 0.0075. Now recall that if P is less than or equal to alpha. I don't know if I pointed this out a minute ago or not, but some books would simply say if P is less than alpha. I've never actually seen one that where P was actually equal to alpha, so your book does P is less than or equal to alpha. So, at alpha equal to 0.10, which is given in the problem, P is less than alpha, therefore we reject the null in favor of the alternative. And conclude there is statistically significant evidence E-D-E-C-E that the mean number of insect parts in wheat flour is not fit for human consumption. And if you want to add on here, or mu is greater than 75, we should add that in. Okay, so our test statistic, let's put that in to 4 places. 2.4331. Our p-value 0.0075. It's a lot less than alpha equal to 0.10. Okay. You never accept you never accept the null, you just reject you never accept the alternative. You reject the null hypothesis, or you fail to reject it. Okay, so again, 2 options. Either reject the null in favor of the alternative, or you fail to reject the null. So here's that. Now, it can be tricky on what the claim is. Normally, the claim is the alternative hypothesis. Sometimes I have seen where the claim is the null. So you just really have to read the problem and see. In this case, our claim is no. That's how to say reject sport. Our claim is that it's greater than that it's more. So no, there's enough evidence to support the claim. So again, the claim is that they think there's more than that. And what is the type 1 error for this situation? So recall type 1. When we reject the null when we really shouldn't. We reject the null in favor of the alternative. So that the FDA says the flour is fit for consumption, but there really was more than that. Okay, so the flour, yeah, this would be your type 1. The FDA believes the flour is contaminated when it's really not. That's again, you when you reject the no when we really shouldn't. So let's go there and submit that. Now I'm going to pull up StatDis and show you what we have to do there. It's over here. Okay. So on StatDis, analysis, hypothesis testing, mean one sample. Now, make sure you get your alternative correct because by default it comes in as a not equal. So your alternative is that your population mean is greater than the claim mean. Okay? Significance is going to be 0.10. The claim mean is 75. The population standard deviation was 9. The sample size is 37. The sample mean, X bar, is 78.6. Now, your sample standard deviation, the TI calculated that for you. Okay, this is not going to do that. So for your sample standard deviation here, I'll write this down on StatDis, which is S. That's going to be sigma divided by the square root of n, which would be 9 divided by the square root of 37. Okay. So let me bring the TI back up here. So I have to do 9 divided by the square root 37. And I'm going to take this to 4 decimal places, 1.4796. So you have to do one little extra step in StatDis. 1.4796. And let's evaluate. Okay. So let's look at what we got and compare it. 2.4331, 2.4331. Okay, same thing here. We're not going to worry about critical Z's. We just going to look at our p-value, 0.0075, 0.0075. Let me know if you have any questions. Thanks.